Today's video is one of the more important ones for me. Today we're going to be talking about screen transitions. In my game, I am looking to mimic that scrolling style of room or level transitions that you see in the old school Zelda games or Mega Man games. Konami used it also in some of their games from back in the 80s and 90s. So one thing I decided to give a shot is to get ChatGPT to create the code to create these room transitions for me. I think there's a lot of potential in getting AI products and tools to do some coding for you. I know vibe coding is a whole like cultural shift in the modern day, um, and I think it's powerful. It has potential for sure. But let me show you the code that ChatGPT created for me. So I've got here showing in Notepad the solution that ChatGPT gave me. On the surface of things, it looks good. Um, we're going to need an object that triggers the sequence of the transition. So to get it started, we're going to have a persistent controller object that's constantly checking to see if there's a room transition happening or not. I do have an object in the game called object game that sort of listens for the general triggers, if I can call them that, in the game. But it's good to have a dedicated object that's simply listening for room transitions. So bonus points to ChatGPT for that one. That's a good idea. I'm just quickly scrolling through it for those that are interested in looking at it. I'll include a copy of the code in the description below if you want to take a look at it. The code by Claude or Claude, or if you speak French, Claude. So very similar. There's a transition manager, and then it goes over the variables, the step event, which is run every frame. Again, I'll include this in the description below if you want to take a look at it yourself. I thought this solution was better than the ChatGPT solution, to be honest. But again, I couldn't just copy and paste this code and it would magically work. It kind of gives you a good outline or a template. In my opinion, AI generated code will generally provide a good template that you can then implement and adjust as you need to. I tried doing that and it didn't work, and I'll tell you why. Both of the solutions deal with surfaces. So surfaces in Game Maker are basically canvases. Before we dive into surfaces, let's just look at, I'll quickly skim over the rest of this code. But, yeah, player object modifications. So in this solution, they're getting the player object to detect if they're hitting with a transition or a door object. In my solution, I made the door object, the one that's checking if it's colliding with the player. Doesn't really matter. In Claude's solution, these usage instructions were really cool, I thought. It explains how the code is supposed to work in a way that I think is more thorough than the ChatGPT version. If I had to pick one of the two, again, the Claude version is better. I preferred its solution, just in terms of readability, like the instructions, as I said. Again, I tried copying and pasting both of these solutions, getting it to work in my code. And the biggest obstacle for me was that each of the solutions deal with surfaces. So I just quickly switched back to ChatGPT, but they both do this. The way that they deal with surfaces is that there's two sets of surfaces. Again, a surface is just a blank canvas. But I didn't have a very good understanding of how to implement surfaces in GameMaker at all. So I figured it's just better for me to learn how to use them. And then I just created my own solution, though I did mimic a lot of the steps or the ideas that both sets of AI code provided, which is cool. It kind of pointed me in the right direction. So again, I think it's kind of cool. I did find it helpful in the long run, but it didn't save me time the way I thought it would. I ended up doing the work anyway, but I don't regret it. In fact, I'm probably going to use it again for other coding. For instance, like boss coding. If there's a boss that I wanted to do a certain pattern, I'll probably get Claude. I'll use Claude, I think, to give me something and to work with. Okay, so before I show you my solution, my solution depends currently the way I've coded it. It's kind of hard coding the resolution of the game. So in my camera object, I had originally set my resolution to, it's the same ratio, but to 640 wide and 360 pixels tall. And I'll show you what that looks like when I run it. Okay, so it's only showing half the, it looks kind of awkward, but it's, what I want to bring to your attention is what the game looks like at this resolution compared to this one. I think this looks better. I think this is going to be more fun to look at. There's less screen in a way, um, which I think will feel better. Um, in the other resolution, the 640 by 360, I just think it's zoomed out too much. I know there's some games that kind of use that style, but I'm going for that old school feeling, that retro feeling. Um, this feels more retro to me, feels better when I look at it. Okay, so check this out. I have my transition door object here in shaded green. This is what it looks like, the final product. Okay, I'm going to restart it and do it again. So here's the transition. Okay, now to sort of look at the code. I'm going to go to the room. I haven't adjusted the resolution yet. But here's my transition object. And the way that these transitions work, in GameMaker, this is kind of like a general room transition solution. Each instance of these doors, you have to go to the creation code for each specific instance, and you need to set these variables. Um, target room, self-explanatory. What's the next room? Direction I'm using to determine if you want to slide to the right, up, to the left, or down. What direction are we moving to? Which then dictates what direction are the images of the levels sliding. This x, my x, is hard-coded. And these variables use my x and use my y. So use my x is set to true because we do want to use that coordinate. X is going to be equal to 318 when our player moves to the next room. Use my y as false. And the reason we're setting this to false is, again, if you think of Mega Man, if Mega Man is jumping into the boss room, he kind of floats. His y coordinate, or the player's y coordinate, is consistent as they slide. So anytime we're moving across the x-axis into a different room, I want that y value to stay the same, so that if you're jumping, you're kind of jumping as you transition, so that you're not falling or rising up, so that value is static as you're moving in between rooms. Similarly, if you're going to go up and down in a level, your x coordinate, I'm going to keep it fixed to what it was from the previous room or part of the level. That's what makes sense to me. And that's what we're doing. Take a look at my objects. So that's object door. We just talked about that. Here's my persistent object. So this is an object that is created at the beginning of the game and is invisible, but it's going to be there in every part of the game. I'll just take a quick step back and explain how that works. If I go to my rooms, I have a room called room init or initialize. When we take a look at this room, it's nothing. It's nothing but these invisible objects. So this object, game object, is what starts everything else. So it's kind of the foundational object. My camera, I initialize the camera before we go to any part of the game. I have object pause. I talked about this in my last video. This is what I'm using to pause the game, but also to do those hit stops effects, so that you have those fractions of a second whenever you punch an enemy or hit an enemy, or if you get hit. I am going to do screen shake, I think, but that's going to be a separate thing that's done within the camera object. But I digress. That's not important at the moment. And then I have my transition listen object. So any persistent objects outside of the player, I'm initializing in this room, this first room. So most of the persistent objects in my game, I'm initializing in this room before anything else happens. But that's including the object transition listen object. The other two objects I want to talk about are transition slide in and slide out. So slide in is going to create a sprite using the current level background. Okay. I wanted to remove the image of the player first, but that's not what I'm doing. So I'll just get rid of that. So I'm taking the camera width. I multiplied by 4. I got to be honest, I'm not entirely sure why I needed to do that, but it works when I do. So I think this is something I'll have to revisit eventually. Right now, if it works, if it ain't broke, you don't fix it. Not now. I'm kind of happy with this. So again, I'm creating a sprite based on the image of the screen before the transition starts. And then in this draw GUI event, this is when we're sliding. 8 is the number of pixels that I'm using if we're sliding on the x-axis. 5 is the one we're sliding on the y-axis. I might change these numbers, but that's not really important right now. Yeah. And then in the step event, I'm checking if our sprite is off of the screen by comparing it to where it originated. So let's say you're drawing it at 0, 0. The coordinates you're using to draw your sprite are 0, 0. X origin is going to be 0. And depending on what direction we're going, once I'm a whole camera width away from where I started and I've reached my limit, if limit is reached, destroy the instance. Another thing to note about sprites that you're creating dynamically, if you're creating dynamic sprites, you want to delete them when you're done. So in the destroy event, when it's time to destroy this slide in object, we're going to delete the sprite that it created. You can get memory leaks otherwise. It's a whole thing. So good practice. Dynamic sprites, dynamically created sprites, delete the sprite when you're done with them. Similarly with my slide out, it was commented out. Actually, I'm going to do that at the very end. But yeah, similarly with my slide out, the other sprite that I'm creating dynamically, you want to make sure it's deleted. This one, when the slide out object is created and I create the sprite, I'm just going to mimic what the slide in object is doing. its X and Y coordinates are going to depend on where the slide in object is located. So I'm doing that in the create event. Once I know where I want to place it, I create my sprite down here. So again, I'm using the same sort of strategy. I'm going to have an X origin and a Y origin for my sprite. I'm going to create my sprite. And then in the step event, similarly checking if we reached our limit. So the creation of the slide in and slide out objects is done in my transition listen. So the reason I'm using this room start event, if I'm not in the very first level of the game or in the very first room of a level, when we're starting in the next room of the same level, I'm using this alarm event. Why am I using the alarm event? We're using this alarm event because if I try to capture the screenshot of the new room in the same frame as when we created our, okay, let me, hold on, 3, 2, 1. In the object transition listen object, we're using the room start event to set an alarm, and that alarm is where we create the slide out object. The reason that I use an alarm is that if I create the slide out object in the same frame as the slide in object, even if we've changed rooms, it's going to take a picture of the old room. The draw event or drawing our sprites is one of the last things that's performed, one of the last tasks performed in any given frame. So the surface that we're using to capture and to create that sprite, the surface that we're using actually doesn't get updated until the next frame. So that's why I'm using this alarm event, is so that we can go through the next cycle, go to the next frame. Now when we create our transition slide out object, it's going to use the new room's image to create our sprite. So that's super important. Otherwise it doesn't work. You're just sliding in two copies of the same sprite. And I also have this variable ready to draw because I don't want to start drawing until I've captured this second or created the second sprite. So now that we've created our second sprite, both the slide in and the slide out objects are ready to draw. And again, I'll show you, I'll quickly show you what that looks like now that I've gone over the rough explanation. Okay, two things I want you to notice. Number one, the scrolling background. It's a bit jittery when I slide into the next room. The second thing I want you to notice, the alpha value or transparency value, kind of in these areas, these lightly shaded teal areas, because there's transparency, you're going to see the player in the next room at the bottom right. Watch. I'm going to do it again. So two changes I need to make, and I'm not really worried about it. is number one, I'm not going to use um, I'm not going to use backgrounds that have any transparency in them, or I'm going to be more selective about it because it's just kind of ugly when you see the player, an image of the player as the screens are scrolling. I mean, it's not a good look. The other thing I'm going to change is that the backgrounds are only going to be scrolling, or I'm going to pause their scrolling if we're changing rooms. So you can see it's working well for the original room. It doesn't really draw that scrolling, but I think there's sort of this odd scrolling effect. Yeah. So in the new room, I'm going to have to stop it from scrolling. I think that's part of the problem here. Or I might not even draw the background altogether. I know I've seen that in other games where backgrounds are kind of removed as you switch to different parts of the level, and then they just start again. They show up again once you're in the next room. Let me know if you have any questions in the comments section. I'm more than happy to oblige, take a look, answer as best as I can, or find out the answer. Until next time.